capital letters to denote the set and lowercase letters to denote the elements of that set. Okay. So after that we have seen different terminologies. In that we have seen first definition is for inclusion, or we can say subset, definition for subset. So if there are two different sets A and B, then A is called as subset of B if all the elements of A are present in B. Okay. So again, that subset is also called as concept of inclusion. So we can say A is subset of B or B includes A. So based on that we have seen some examples. Now next point is for equality. So again we have seen when we can say that two sets are equal. So if there are two different sets A and B, and if A is subset of B and B is subset of A, then we can say that A and B are equal sets. After that, we have seen what is the definition for inversal set. So set which includes every set under discussion is called as inversal set, and that is denoted by capital letter E. After that, we have seen what is the definition for empty set. So set which does not contain any element, that is called as empty set, and this set is represented by symbol phi. Then next point is for power set. So we have seen power set means what? Collection of all the subsets, and formula for that power set is 2 raised to A, where A denotes number of elements in that set A. So again we have solved some examples based on power set. Now in this lecture we are going to see what is the power set and how we can introduce a notion to denote a power set. Okay, so here one example is given. Suppose here set S2 is given, and S2 is containing two elements A and B. Okay, now we have to give representation for each and every element of this power set. So first of all we have to find out how many elements would be there in power set of S2. So can anybody tell how many elements would be there in power set of this S2? Yes. So in the last lecture we have seen what is the formula to find out number of elements in power set, and that formula is 2 raised to A. So consider this set as A. So A means what? Number of elements in this set. So here those elements are 2. That's why 2 raised to 2. That is equals to 5. Again we have seen phi is a first element of every power set. That's why first element is phi. Phi means what? Empty element or empty set. Then next element is set A, then set B, and last one is set A comma B. Okay. Now we have to represent each of these set by some symbols. Okay. So here we have to consider its binary representation. So phi means what? It is an empty set. So this phi can be represented as B00. 0. Means what? This 0 is for A and this one is for B. Means what? Nothing is present in this phi, either A or B. That's why it is represented by phi. Okay. Now suppose we have to represent set A. Okay. Now check here. A is a first element of that set. That's why it should be represented as B10. So here this 1 indicates there is presence of A in this set, and 0 indicates there is absence of element B in this set. That's why set A is represented by B10. Okay, so likewise we have to represent set B. So again here absence of A, that's why B01. A is absent but B is present in this set. That's why its representation is B01. And next one is, in this set it is containing both the elements as A and B. That's why it should be represented as B11. Are you getting this? Hello?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So likewise, suppose there is another set which is containing 3 elements A, B, C. Now we have to represent the element or set C. Okay. So that should be represented as B, that is for binary. Again, A and B are absent. So for that purpose we have to write here 2 zeros and then 1. So this 1 will indicate presence of C. So suppose again we have to represent any set which is containing elements A and C. So B1, 0, 1. So here 0 means what? What this 0 indicates? Is absence of B. And if you want to represent set B and C, then it should be represented as B011. Okay. So here one example is given. Let S6. So here 6 represents, there are total 6 elements in this set from A1 to A6. Okay. So there would be 2 raised to 6 subsets of S6. Then which are the designates by B0, B1 and B2 raised to 6 minus 1. Okay. Now here they have given, we have to find out any set which will represent B7. Okay. So first of all we have to find out what is the binary representation of 7. So I think you have seen this in DT, how to find out binary representation for any number. Are you aware about this, how to find out binary representation?
Yes, ma'am.
Okay. So can you tell me how this 7 can be represented in binary?
111.
Yes, 111. Okay. So here we have got the binary representation for 7 is 111. Okay. But in this given set, there are total 6 elements. So how many elements are still remaining? 3 elements. So before this 333, we have to add those many elements. Okay. So 333 are added here. So now count 1, 2, 3, 4, 5, 6. So there are total 6 elements. Okay. Now this set is complete. Now we have to find out what are the different elements, those are present here. So count from this element. So A1, A2, A3, A4, A5, A6. So again here 0 indicates absence of element and 1 indicates presence of element. So here A4, A5 and A6. These 3 elements are present. That's why this set will contain 3 elements A4, A5 and A6. Have you understood? Hello?
Yes, ma'am.
Okay. Now suppose B12 is given set and we have to find out what are the different elements included in this set. So how we can find out? Just tell me procedure, how we can find out? Again same, first of all we have to find out binary representation of 12 and it is coming as 1100. So again, this set is containing 6 elements. So still 2 elements are to be added. Those are added here as zeros. So now check 1, 2, 3, 4, 5, 6. Now this set is complete. So whenever 1 is written there, we have to consider as presence of that element. So now count A1, A2, A3. So A3 is present. Again A4 is present. A5, A6. So only 2 are there. So those elements are A3 and A4. So likewise we can represent any set, or we can represent any power set in terms of binary representation, and from that we can find out what are the different elements those are present in that set. Okay, so next example you have to solve. So in this given set there are total 8 elements. So here we have to find out any subset represented by B17 and B31. Okay. So first of all, find out the number of subsets or number of elements those are included by B17. Okay, first of all tell me what is the procedure, how we can find out?
Find binary representation of 17.
Is
And
binary
31.
representation of 17 and 31. So what is the binary representation of 17?
10001.
10001. Okay. So that representation is containing how many bits?
5 bits.
5 bits. So still 3 bits we have to add, and those bits will be 0. Now here this B17 will contain elements are A4 and A8. Okay. So likewise again this B31 will include the elements as A4, A5, A6, A7 and A8. So these examples are solved here. Okay. So in this first of all we have to find out binary representation of 17, and that comes as 10001. So this is containing just 5 bits. So to make it complete we have to add 3 more bits, and those bits would be 0 before this string. So again we have to check what are the different elements are present. So whenever we have written 1, it will indicate presence of that element. Okay, so count from this element A1, A2, A3, A4. So first one we have written here. So A4 is present in that set. So again A5, A6, A7, A8. So this B17 will contain 2 elements as A4 and A8. So likewise we can find out binary representation of this. So here also we can find out binary representation of 31, and again we can find out what are the different elements would be there in that set. Okay. Now next point is we have to find out the subset A2, A6 and A7. So what is this subset? Okay. So again there is another procedure how to find out it. Okay. So what are the subsets given? A2, A6 and A7. Okay. So first of all we have to take 8 bits because our set is of 8 bits. So first element is A1, but that element is not present in this subset, so it should be represented as 0. Okay. Now next element is A2, that is present, so it should be represented by 1. Again, for A3, A4 and A5, it should be 0 as those elements are not present here. Again, A6 is there, so we have to represent it one as 1. A7, again 1. A8, again it should be represented by 0 as that element is not present in this subset. Okay. Now we have to find out what is the value for this subset. So we have to convert this binary into decimal format. Okay. So start from left. So first element is 0. So next one is 1. So 2 raised to 0, 2 raised to 1, 2 raised to 2. Again for this one it will give you 2 raised to 6. Now find out what is the decimal value. 2 raised to 0. Again it is 1, 2 raised to 1, 2, 2 raised to 2, 4 and 2 raised to 6. It is giving you 64. So what is the total value? I think some mistake has happened here.
71
No,
element.
madam, correct. आहे.
No, this 0. Here is 0. Yes, that's why 2 raised to 0 we are not going to consider. If 1 is there, then only we are going to consider that value. So this value is correct as 70. Have you got how to find out value
Yes,
for
ma'am.
given subset? Okay.
Yes, ma'am. Yes,
Good.
ma'am.
Now next one, for again this same set you have to find out what is the value for this given subset, and that subset is containing two elements A1 and A8. So take time of 2 minutes and find out what is the value for this given subset.
One 29.
Hello, how much?
129, madam.
129. Okay. Any another answer? Yes, 129 is a correct answer. So first of all we have to check what are the different elements present here. A1 is present, then A2, A3, A4, A5, A6, A7. Up to this we have to write there 0 as those elements are not present in this subset. Now next element is A8, that is present. That's why we have to write here 0. Okay. Then again for this 1 means what? Presence of element. That's why 2 raised to 0. Again 2 raised to 1 up to 2 raised to 6. Nothing is present there. That's why we are not going to consider it. And last one, its value is 2 raised to 7. So 128 plus 1, it will give you 129. Okay. So 129 is a correct answer. Okay. So here we are going to solve some examples. Question number 1. Given set X that is containing 3 elements 1, 3, 5 and Y is containing 5 elements 1, 2, 3, 4, 5. So here we have to find out whether X is a proper subset of Y. Now check whether X is a proper subset of Y. So what is the concept of proper subset? Last lecture we have seen this point. What is the definition for proper subset? So first of all, tell me whether X is a proper subset of Y. Yes or no?
Yes, ma'am.
Yes. Why?
Yes, ma'am.
Why it is proper subset of Y? Yes, we have seen definition for a proper subset as if there are two different sets A and B, then if A is a subset of B but A is not equals to B, then only we can say that A is proper subset of B. So likewise here are two different sets X and Y. Now first of all we have to check whether X is a subset of Y. Now check whether all the elements of X are in Y. Yes, 1 is present, 3 is present, 5 is present. So all the elements of X are in Y. So here we can say that X is a subset of Y. That first condition is satisfied. Now what is the second condition? X must not be equal to Y. No, so X is not equals to Y because Y is containing some more elements, those are not present in X. So both the conditions are satisfied, so X is a proper subset of Y. Okay. Now next question. Two sets are given, X and Y, and we have to check whether those are equal sets. Now look at the elements and tell me whether these are equal sets. Hello? Hello?
Ma'am. Yes, ma'am.
Check whether these two sets are equal, X and Y.
Yes, ma'am.
Yes, because X and Y are containing same elements, that's why these are equal set. Now next one, given X is equals to 1, 2, 3 and Y is equals to set 1, 1, 2, 3. Now check whether X is equals to Y.
Yes, ma'am.
Yes,
Yes, ma'am.
yes, because 1 is present in Y, 2 is present in Y, 3 is present in Y. Again, if you check, Y's first element is 1 and that is present in X. Again 2 is present, 3 is present. So here there is just repetition of 1 in set Y. So that would be considered as only one element as 1. That's why X is equals to Y. So next question is write the following sets in the set builder notation. So here we have to give written explanation about given sets. Okay. So first set is given as 1, 3, 5, 7. So how we can define this set?
Set of odd numbers.
Is correct. Set of odd numbers. Next one. How we can define this second set?
Set of even.
Set of even numbers, but that limit is there up to 10. So here we can say that
From
this
1 to
set
10.
is this set will include even numbers from 1 to 10. And last one, what these letters are called? A, E, I, O, U.
Set of vowels.
Yes, correct. Set of ovals. Okay. Now next question. Write all the subsets of given set. And this set is containing three elements 0, 1 and 2. So here you have to find out power set of given set. So find out what is the formula to find out power set.
2 raised to power A.
2 raised to A. So A indicates number of elements in that set. So here that number is
3.
3. So 2 raised to 3, that is equals to 8. So tell me what would be different elements. First element of power set is always
Null set.
Null.
that is 5. Okay. Then next element
Zero. Only zero and then one, then two.
set
1,
0,
2,
set 1
1,
and
0.
set 2. Call this one as
Yes, ma'am.
set. Okay. 5, set 0, set 1, set 2, set 0, comma 1, set 1, comma 2, set 0, comma 2 and set 0, comma 1, comma 2. That is this given set. Okay. Now suppose B is given as 1 and 5. So how many elements should be there? 2 raised to 2, that is equals to 4. Now tell me what are those elements in power set of B? Again same, first element of power set is always which element?
5.
Null
Null
set.
set.
Null set or 5. The next element is
1.
set 1. Don't call this one as only 1. Meaning of 1 and set 1 is different. So you have to write there set 1. Then next one is set 5. And last one set 1, comma 5. Okay. Next question. If X is containing 4 elements as 1, 2, 3, 4, find power set of X. So you have to tell me what are the different elements. First of all, find out number of elements in power set of X. So 2 raised to 4 and that is equals to
16.
16.
16.
Okay. Now tell me what are the different elements. First element
Null set.
5, that is null set. Okay. Next element set 1, then set 2, set 3, set 4, then set 1, comma 2, 2, comma 3, then set 1, comma 3, set 1, comma 4. Again here set 1, comma 2 and 2, comma 1. These are same. So we are not going to consider these one are different. Then set 2, comma 4, then 3, comma 4, set 1, comma 2, comma 3, then set 2, comma 3, comma 4. Likewise, now count how many elements are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. So there are total 16 elements if your set is containing 4 elements. Okay. So up to this, have you understood what is this set theory?
Yes, madam.
Okay,
Yes, madam.
good. So next question is indicate which are the finite sets. Now first example is given for x is an integer and it lies between 5 and 12. Now whether this one is a finite set? Yes, because this is containing finite set of elements. Now next one B. B is this is containing the elements 2, 4, 8 dot dot. So it will indicate this one is as infinite set. Next, all the countries of world. Yes, those are countable. That's why this is a finite set. Okay. Now this part is very important. Here set S and R are given. So indicate whether following are true or false. Okay. So first one, set A belongs to S. Answer is given as false. So you have to tell me explanation why this statement is false. Yes, why it is false?
Element A belongs to
Element A belongs to
yes.
S, but set A does not present in set S. That's why this statement is false. Now next one, set A belongs to R. Now check whether set A is member of R. S. That's why it is correct statement. Next, set A4 and set 3. This set is subset of S. Now check whether all these elements are present in S. A is present, 4 is present, and set 3 is also present.
Yes,
That's
ma'am.
why, yes, that's why this one is true statement. Now next one, set containing set A 1, 3, 4. This is proper subset of R. And answer is written as false. So why this statement is false? Again here we have to apply the concept of proper subset. If given set is subset of R and if it is not equals to R, then only it is called as proper subset. But if you check here, all the elements of R are given here. So this set is equals to R. That's why this is not a proper subset of R. So your answer is false. Now check whether R and S are equal sets. No, these are not equal sets. So answer is false. Next, set A is subset of S. True or false?
True.
True. Correct. Because A is element of S. That's why set A is a subset of S. Now, set A is subset of R. Why this statement is false? Can you tell me what we would have to write here in order to make this statement as true?
Set of set A will
Correct.
subset
Set
R.
of set A is subset of R. Then only we can write here true. And phi is subset of set 3, 4. Yes, this statement is true because phi is subset of every set. So again, in next question, set is given and that is containing elements A, set B. And here we have to find out its power set. So again, first element of that power set is 5. Next element is set A. Then hello. Okay. Set of set B is with hello.
Hello, ma'am.
Which question?
Ma'am, set is the subset of R.
Hello.
How, ma'am?
Question 2. This one.
Question 2, ma'am.
Hello. Okay.
Yes, ma'am.
So here what is
Hello, ma'am.
so here we have written set A.
Set A is the
Okay.
subset of R.
Check here when set A belongs to R. Okay. So here set A, check whether that element is present here. Yes, set A is present in R. That's why set A belongs to R. That statement is true. But if you consider here what we have written, set A is subset of R. Okay. Now check, in order to find out its subset, for each and every element of R we have to put brackets like set of set A, set of 3, set of 4, set of 1. Then only we can say that each and every element of this set is subset of R. But what we have written here, just set A. So set A is member of R, not a subset. So in order to make it subset, we have to put another bracket as set of set A. Then only it would be subset of R. That's why this statement is false. Hello? Rutuja, have you understood? Have you understood now? Okay,
Yes, ma'am.
good.
Yes, ma'am.
So here in this example, in the power set of this given set, first element is 5, then next element is set A, then set B, that is set of set B, because already set is here, and in order to find out power set we have to put extra brackets. So set of set B, and last set is set A comma set B, that is given here. So this is the power set of given set. Now here next example is given, and that is containing 3 elements as x comma y comma z. So you have to find out what is the power set for given set. So first of all, tell me how many elements would be there in power set of given set?
3.
3 elements. First element is okay, tell me what are those elements in a power set of given set? Number of times we have seen first element of power set is always 5. So first element is 5. Second element
X. Set
set
X.
X. Okay. Next
Set Y.
set Y.
Set
Then-
Y.
Okay. Next
Set Z.
set Z. Then
Set X comma Y.
set
Set
X
X,
comma
Y.
Y. Okay.
Set Y.
Set Y comma Z. Set
Z.
X comma Z, and
X
last one.
comma Z.
Okay. And last one
Set
is
X comma Y comma Z.
okay. So this will totally includes 8 elements. Next question, given set S1, it is containing elements from A1 to A8. Okay. Then what are the subsets represented by B19, B31, and B124. So these kinds of problems we have seen earlier. So first of all, tell me how we can find out subset for these elements. B19. So what is the procedure we have seen?
First, we have to convert it by.
Speak loudly.
First, we have to convert into binary
Okay.
form.
So first of all, we have to find out what is the binary representation of 19. So binary representation of 19 is given as 10011. Okay. So again, there are total 8 elements in given set. So that's why we have to add remaining elements. So total 5 elements are here. So still we have to add 3 elements as 3 zeros before this string. So first 0, A1, A2, A3, A4. So for this A4, 1 is there. So we have to write here A4 as subset. Then 0, 0, A7, A8. So this B19 will include sets as A4, A7 and A8. 31, we have seen this. Okay. So these are the some examples based on what we have seen in set theory. Now we have to see the next point, that is operations on sets. So this is very important point. So different operations are given on sets. First operation is intersection operation. So the intersection of any two sets A and B is written as A intersection B. So this will consist of all the elements which belongs to both A and B. Okay, and this intersection is represented by this symbol. So A intersection B. So here this is the symbol for intersection. This is equals to for any element X, X belongs to A and X belongs to B. Okay. So in short we can say that the elements which are common in A and B, those will be included in intersection of A and B. Okay. So here some proofs are given, that is A intersection B. This is equivalent to B intersection A. Again A intersection A, this is equivalent to A. A intersection phi, this is equals to phi. Okay. So first we have to prove this first statement, A intersection B, this is equals to B intersection A. Okay. So in order to prove this statement, we have taken one element X. So for any element X, X belongs to A intersection B. Okay. So we have to write its equivalent form. So keep this X belongs to as it is, and now whatever definition we have seen for intersection of A and B, we have to apply here. So X belongs to this definition for A intersection B as for any element X, X belongs to A and X belongs to B. Okay. Again, if you consider X belongs to for any element X, X belongs to A. This is definition for X belongs to A. Okay. And again, X belongs to for any element X, X belongs to B. Means what? Ultimately that element X belongs to B. So till now we have got X belongs to A as well as X belongs to B. Again, this operation is AND operation. So P and Q, this is equivalent to Q and P. Likewise, here we can alternate or interchange the position of A and B. So first we are going to consider X belongs to B, then AND X belongs to A. Meaning of these two statements is same. Okay, so again, x belongs to B means what? For if you take x belongs to common, so x belongs to for any element x, that element x will belong to B as well as in set A. So this is the definition for B intersection A. So in this way we can prove A intersection B, this is equivalent to B intersection A. Have we understood? Or shall I repeat this once again? Hello?
Once again.
Okay.
Repeat.
Okay. So here what we have written, for any element x, एक element consider केला आपण x, and that is belongs to both the sets A and B. So x belongs to A intersection B. So what we have done here, x belongs to we have kept as it is, and we have applied definition of A intersection B here. That is set containing any element x, and for that element x, that x belongs to A and x belongs to B. So in this step we have just applied definition for A intersection B. Okay. आता ह्याचं मिनिंग काय आहे बघा, एक एलिमेंट x आहे तो सेट A मध्ये पण आहे आणि B मध्ये पण आहे. मग ते आपण कसं रिटर्न केलंय, x belongs to A and x belongs to B. So meaning of these two statements is same. Again, we can change the position of B and A, because A and B, this is equals to B and A, because this is a AND operation. That's why x belongs to B and x belongs to A. इथपर्यंत समजले का काय केलंय? हॅलो? Okay.
Yes, ma'am. Yes.
Now, again, here x belongs to, we have keep this outside because that is common between both the brackets, and what is remaining, B and A. म्हणजे काय, तो एलिमेंट सेट B मध्ये पण आहे, सेट A मध्ये पण आहे. तेच आपण इथे लिहिलंय, फॉर एनी एलिमेंट x, x belongs to B and x belongs to A. Means what? That element is present in B as well as in set A. So this will give you B intersection A. That's why A intersection B is equivalent to B intersection A. Have you got now?
Yes, ma'am.
Okay. So here we can say that this intersection operation is associative. Why? Because A intersection B intersection C, this is equivalent to A intersection B intersection C. So here we have changed just brackets, so it satisfies associative property. So take note of these two statements. You have to prove it. A intersection A is equals to A and A intersection phi is equals to phi. So can you tell me how we can prove these statements? Just orally tell me how A intersection A becomes A. First of all, tell me what is meaning of A intersection A.
Intersection means common elements present in both. At A intersection A
Yes,
means
common
all elements
elements.
in A.
Okay,
In both.
that's fine. That is A only.
A intersection A means A.
Okay, correct. And next one, A intersection phi is equals to phi. Why this one is equals to phi?
Phi means no
what?
element.
No element. That is empty set. So if you take
And
intersection of phi with any element, you will get answer as phi only. Okay, fine. So give presentee. Roll number 1.
Yes, ma'am.
Roll number 2. Roll number 2. Absent. Hello. Roll number 2. 3. 4.
Present, ma'am.
5. 6. 7. 8. 9. 10.
Present, ma'am.
11. 11 is present.
Present, ma'am.
Okay. 12.
Present, ma'am.
13. 14. 15. 16.
Present, ma'am.
17. 18. 18. 19.
Present, ma'am.
20. 21.
Yes, ma'am.
22.
Present, ma'am.
23. 24.
Present, ma'am.
25.
Present, ma'am.
26.
Yes, madam.
27. 28.
Present, ma'am.
29.
Yes, ma'am.
30. 31.
Present, ma'am.
32.
Present, ma'am.
33.
Present, ma'am.
34.
Present, ma'am.
35.
Present, ma'am.
36. 37. 38.
Present, ma'am.
39. 40.
Present, ma'am.
41. 42. 43. 44. 45.
Yes, ma'am.
46. 47. 48.
Yes, ma'am.
49.
Yes, ma'am.
50.
Yes, ma'am.
51.
Present, ma'am.
52. 53. 54. 55. 56.
Yes, ma'am.
57. 58. 59,
Yes, ma'am.
60, 61, 62,
Present, ma'am.
63,
Present, ma'am.
sec- okay, 64, 65,
Yes, ma'am.
66, okay,
Present, ma'am.
67,
Yes, ma'am.
68,
Present, ma'am.
69,
Hello, madam.
okay, yes,
Hello. 2 is present, ma'am.
okay,
Ma'am, 42 is present.
42,
Ma'am,
Yes,
7.
7,
7,
yes, any another number?
23, ma'am.
23, प्रेझेंटी होता ना घेताना कुठे होता मग तुम्ही?
रेंज प्रॉब्लेम आहे, काहीच ऐकू येत नव्हतं.
बर बर, 67, ओके. Okay, so now we have to see the next point as disjoint set. So first we have to see what is the definition for a disjoint set. Two sets A and B are called as disjoint if and only if A intersection B is equals to phi. Means what? If nothing is common between A and B, then only we are going to say A and B, these are the disjoint sets. Okay, again, next definition is for mutually disjoint or disjoint collection. A collection of sets is called as disjoint collection if for every pair of sets in the collection, two sets are disjoint. Means what? If you consider the multiple sets, okay, that is collection of sets, and if you pick any two sets, if those two sets are disjoint, then this collection of sets is called as disjoint collection. Okay. म्हणजे काय, जर त्या सेटमधला तुम्ही कुठले पण दोन सेट चूज केले आणि प्रत्येक पेअरसाठी जर डिजॉइंट सेट आले तर आपण काय म्हणणार आहे, दॅट कलेक्शन इज कॉल्ड ॲज डिजॉइंट कलेक्शन. नाउ हियर वन एक्झाम्पल इज गिवन. Set A1, A2 and A3 are given. Then show that A1, A2, A3 are mutually disjoint. Means what? What we have to show? We have to choose pair of elements or pair of sets as A1 and A2, A2 and A3, A1 and A3. Okay. So if you choose A1 and A2, now check whether anything is common between these two sets. First element in A1 is set 1, 2. Here first element is set 1. Again, second element in A1 is set 3. In A2, it is set 2, 3. So nothing is common between A1 and A2. That's why A1 intersection A2 is equals to phi. Again, if you consider another pair, that is A1 and A3, again check whether anything is common between A1 and A3. No, nothing is common. That's why we have to write here phi. Again, if you choose another pair as A2 and A3, again nothing is common between A2 and A3. That's why that should be written as phi. So this collection of sets is called as disjoint collection, or these sets are mutually disjoint because nothing is common between pair of sets. Have you understood what is the meaning of disjoint collection? Hello? Hello?
Yes, ma'am.
Yes, ma'am.
Okay. Here we have to prove A subset B, this is equals to A intersection B, and this is equals to A. So first is given as A is intersection of B. So what is meaning of A intersection B? Every element of A is present in B. Then only we can say that A is intersection of B. Okay.
Madam,
So if you A is subset of B. So again, what is meaning of A intersection B? A intersection B means what? Whatever common between A and B. Okay. So this is equals to A. So can anybody tell with the help of example how these three statements are equal?
Madam, B is set 1, 2, 3 and A is set 1, 2. That is
Okay.
A subset of B.
Correct.
Therefore,
Again?
A intersection B means all elements of A contain A are in the B,
A
and
intersection
which
B
not
means elements
all
those are common between A
common
and
in
B.
A and B.
Okay. Yes, and that is equals to set A. That's why A subset B, this is equivalent to A intersection B, and this is equals to set A. Correct. Now, next definition is for union. So, how we can define the union? So, this union operation is opposite to intersection. For any two sets A and B, the union of A and B is written as A union B. Is set of all elements which are members of either set A or set B or both A and B. And this is written as A union B. So this is the symbol for union. So we can define this union operation as for any element X, X belongs to A or X belongs to B. Intersection मध्ये आपण काय म्हटलं होतं? The elements those are common between A and B. That operation is AND. But for this union, we can say element which belongs to A, either A or B or both A and B. Okay, that's why here that symbol is OR. एकतर तो एलिमेंट सेट ए मध्ये पाहिजे किंवा बी मध्ये पाहिजे किंवा दोघी पण, दॅट इज ए अँड बी दोघांमध्ये कॉमन असेल तरी चालतो. ओके, सो हियर ए युनियन बी, दिस इज इक्वलंट टू बी युनियन ए, and this property is called as commutative. Again, A union phi, this is equals to A. Can anybody tell why this answer is A only? A union phi. Union means what? That element should be either present in A or in phi or in both A and phi. If you consider example of set A as set 1, 2. So set 1, 2 union phi. So what is the answer for this? जर तुमच्या सेट ए मध्ये दोन एलिमेंट असतील 1 and 2 and second set आहे phi. Okay, so set 1, 2 union phi. Phi means what? Empty set. So its final answer is set 1, 2, and that is equals to set A. So A union phi is equals to A only. Again, A union A, this is equals to A. Again, this union satisfies the associative property as A union B union C. This is equals to A union B union C. So here you have to prove these statements. So take this one as homework. You have to prove A union phi is equals to A and A union A equals to A, and next one A union B union C, this is equals to A union B union C. So can you prove this? One proof is given here for A union A, this is equals to A. So how we can prove this statement? So consider any element X. So here X belongs to A union A. Okay. So keep this X belongs to as it is and write the definition for A union A. So this A union A should be replaced by its definition as for any element X, X belongs to A or X belongs to A. Same definition of union we have applied here. Instead of B, here A union A. So that definition we have written here. So what is meaning of this statement? X belongs to A or X belongs to A. Okay. So again, this is OR operation. So this is equivalent to P or P. P or P means what? Its final answer is P only. Likewise, X belongs to A or X belongs to A. Means what? Its final answer is X belongs to A. This is one side. Now consider another side, and that side is containing element A. So how we can define this set A? That is equals to for any element X, X belongs to A. Okay, and this is the definition for set A. Set A आपण कसं define करतो? For any element X, X belongs to A, and this is for set A. So we can say that A union A is equals to A. Have we understood? Hello?
Yes, ma'am.
Okay. Now some problems are given here. Here we have to find out what is the union and intersection of these given two sets. So S union Q and S intersection Q. S and Q are given. So first of all tell me what is the answer for S union Q? Union means what? That member should be present in either set S or in set Q or in both sets S and Q.
Ma'am, screen is not visible.
Yes, so what is the answer?
Screen is not visible.
Speak loudly.
Screen is not
It's
visible.
not visible, ma'am.
Why?
Window.
Okay. Hello? I think internet connection has gone. Hello? Hello?
Ma'am.
Yes, ma'am.
Just wait for 2 minutes. I am connecting again. Hello? Hello?
Yes.
Yes, ma'am.
Whether screen is visible?
Yes, ma'am.
Okay. So here in this example, we have to find out S union Q. Means what? All the elements, those are common, or we can say whether that element is present in S or in Q or in both S and Q. Okay. So here first of all we are going to write all the elements of set set S, and that is containing A, B, P, Q. Okay. Again we are going to check for elements of Q. Now Q is containing A, P and T, but A and P, those elements we have already written. That's why final set, that is S union Q, will contain elements as A, B, P, Q and T. If there is any repetition of elements, then we are going to write that repeated element only once. Okay. Now next one is S intersection Q. So here we are going to find out all the elements those are common between S and Q. Now check which one is common element between S and Q. Yes, A is present in both the sets as well as P. That's why S intersection Q will contain A and P. Okay, now next example, set A1 is given and that is containing two elements 1, 2. A2 is given and that is containing elements 2, 3 and A3 1, 2, 3, 6. So here we have to find out union of AI where I is from 1 to 3. Means what? We have to find out union of A1, A2 and A3. Likewise, we have to find out intersection of AI where I is from 1 to 3. So in short, we have to find out union of all three sets as well as intersection of all these three sets. So first, what is the answer for union? 1, 2, 3 and 6. And for intersection, the element which is common between A1, A2 and A3, and that element is 2 here. So this is about union and intersection. Have you understood?
Yes, ma'am.
Okay. Now next point or next operation is relative complement. So definition is given as let A and B be any two sets, then the relative complement of B in A is written as A minus B, and it is consist of all the elements of A which are not elements of B. So this relative complement is represented as A minus B. Means what? For any element X, X belongs to A and X does not belong to B. This is meaning of A minus B. The elements, those are present in set A but not in B. That is given by A minus B. So again, this is equivalent to for any element X, X belongs to A and X does not belong to B means what? Negation of X belongs to B. So this is called as relative complement of B in A or difference of A and B, and that is written by A minus B. Now next definition is for absolute complement. Let E be a universal set. For any set A, the relative complement of A with respect to E, that is E minus A, is called as absolute complement of A. Okay. So in the relative complement we have seen A minus B means what? All the elements those are in A but not in B. So in this absolute complement we are going to consider universal set, that is E. So complement of any set with respect to universal set is called as absolute complement, and that is written by E minus A. Okay. So here if you consider any set A, then absolute complement of A is given by negation of A. That is, negation of A is equals to E minus A, that is absolute complement, and this is equals to, for any element x, E minus A means what? Any element x, so such that x belongs to E, but x does not belong to A. Okay, and this is equals to negation of A. E minus A म्हणजे काय? सगळे एलिमेंट जे ई मध्ये आहेत म्हणजे युनिव्हर्सल सेट मध्ये प्रेझेंट आहेत पण सेट ए मध्ये नाही आहेत, मीन्स व्हॉट? ऑल दी एलिमेंट्स दोज आर नॉट प्रेझेंट इन सेट ए. That's why this is represented by negation of A. Again, negation of negation A, this is equivalent to A, because negation gets cancelled, so it will give you set A. So again, negation of phi, this is equals to E, and negation of E, this is equals to phi. Okay, again, A union negation of A. Okay, all the elements those are present in A as well as not present in A, and that will give you universal set E. Next, A intersection negation of A means what? The elements those are present in A but not present in negation of A. Sorry. Present in A as well as present in negation of A, but there should not be any element which is present in set A as well as not present in set A. That's why that is represented by phi, because this is a empty set, there would not be a such element. So here we have to solve some examples based on relative complement and absolute complement. So 3 sets are given, A, B and C. So here we have to find out A minus B, B minus A, and then we have to show that A minus B is not equals to B minus A, as well as we have to show A minus C is equals to A. Okay, so first of all we have to find out what is the value for A minus B. So we have seen definition of A minus B as the elements those are present in set A but not in B. Okay, now check what are those elements those are present in A but not in B. So what would be the answer for A minus B?
5 and 6.
5 and 6, because 2 is common between A and B, that's why we are not going to consider it. Again, B minus A means what? The set of elements those are in B but not in A. B मध्ये आहेत पण A मध्ये नाही आहेत, असे कोणते एलिमेंट आहेत?
3 and 4.
3, 4.
Yes, 3 and 4. Now A minus C means what? The elements those are present in A but not in C. So those elements are 2, 5 and 6. Okay. Now here we have to show that A minus B is not equals to B minus A. कसं प्रूव्ह करणार आहे? First of all find out. Here we have written value for A minus B is equals to 5,6 and B minus A, this is equals to 3,4. Okay, that's why A minus B is not equals to B minus A. Again, A minus C is equals to A. So what is the value for A minus C? We have solved this as 2, 5 and 6. Now check elements of A. Again, A is containing
2,
elements
5, 6.
2, 5, 6. That's why A minus C is equals to A. Yes,
2, 5, 6.
just one operation is remaining, that is symmetric difference or Boolean sum. That operation we will see next lecture. Okay. So have you understood today's part? Whatever we have seen? Hello?
Yes,
Okay.
ma'am.
Yes, ma'am.
So remaining operations of sets we will see next lecture. Thank you.
Hello, Saidi.